So the audio comes in on this capacitor and this capacitor here. These are 1 microfarad. I've got a 100k resistor going to a DC bias voltage. That sets up the bias point right at the middle of the triangle wave. And the bias point is being calculated in real time by this op amp here. This is a TL04, what is this op amp? 084, that's what it is. So it's a decent audio amplifier. Well, it's not an audio amplifier, it's just an operational amplifier, but it's just set up as a voltage buffer with a low pass filter from the triangle wave, so it'll converge to the average value, which is halfway on the triangle wave, just because of the geometry of a triangle wave. So you don't need to use a potentiometer to tune this. This does the tuning for you. So that's kind of a cool little thing. I got 2 chips, of course, for stereo, but I had an issue with beat frequencies due to some indifferences and stuff. So there was a bunch of squealing and stuff coming from the speakers. It took me a minute to figure out why, but I realized what was going on as soon as I would touch one, and it would and then it would come back. And that's very much characteristic of beat frequencies. I had the same issue with my drone, where the propellers are spinning at different speeds, and you can hear the whoa 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 type of a sound. You got multiple frequency sources that are running, free-running oscillators that are running at very close frequencies, and you just get a little bit of, even the tiniest bit of coupling between them can cause issues. So yeah, anyways, that was fun to debug. So the way I fixed that was I just bootstrapped one to the other. So this one is a slave, and this one's the master, and this one's forcing the frequency into this one, both the triangle wave and the trigger to reset the latch that's inside of this chip. What else? I can't separate the ground lanes very well, so there's not like a good analog versus digital ground. That's very irritating. It's causing a lot of hiss and stuff. That and a bunch of other issues. This is not a good chip to use for a Class D amp. Anyway, then I take the outputs from the chip, and I'm going into a, what is this chip? This is a 7802 quad OR gate. NOR gate. It's a NOR gate. So the output is true. The output is false when either of the inputs are false. I think that's how that works. Look up the logic table for an OR gate. It's basically just ORing the gates together. Using a NOR gate allows me to make this a full bridge configuration very easily. I just set up 2 more of these as inverters strapped off of the output. And that'll allow me to invert half the waves so I can generate my complementary signals. So, yeah, it's quite simple, and I just have a little bootstrap circuit here set up. I had some issues early on where the problem I was having, I was using the wrong goddamn chip. I just pulled these out thinking they were a certain chip. Turned out I was using the wrong ones. So I soldered on the right ones, worked fine. I did the math, well, I pulled out the capacitors, but with these capacitors and these inductors, I set up my resonant frequency to be around 20 kilohertz. So everything after that kind of gets attenuated, and of course the whole circuit here runs at 70 kilohertz, so that should attenuate the ripple to a negligible level. But they're not really necessary because you're not going to hear the high frequency from the speakers. The issue that you run into without adequate filtering here is you're going to get a lot of RF on these wires, and if these are big long antenna wires, they're going to be radiating a whole bunch of crap, and that can cause interference, especially with things like AM radios and stuff. So it's not really an issue here. It can also cause interference as this radiates back to the input and creates subharmonic oscillations and stuff. So yeah, anyways, that's, yeah, so it works though. So it works about as well as I would expect this to work. I should preface this with that, but anyway, yeah, so good luck with your design.